this is a circles question, and specifically asking us about the area of the sector when the central angle is given in radians. It says a circle has a radius of 12 units. If the central angle is pi thirds radians, what is the area of the sector? I wanted to show two formulas that are the same but don't often look that way. So the first one, which we should be more familiar with, is the area of a circle, which is area equals pi times the radius squared. And then maybe you know, maybe you don't, an equation for the area of a sector when the central angle is in radians, and that is area is equal to 1/2 theta times the radius squared. And so those two things look similar but different, but if we can understand where it comes from, then it tends to make more sense than just plugging something into a formula. So when we have a sector, it's a section of the circle, and specifically the section that is measured from that central angle that we're given. And so we want to say what percentage of the total area is that section. In radians, a full circle is 2 pi. In degrees, a full circle is 360, and that part's generally a little bit more familiar to us. If you are familiar with the unit circle, the 2 pi being the full circle in radians makes sense. If not, just know that 2 pi is a full circle in radians. So to take this area, what we're doing is we're saying, okay, the area is going to be what piece of the whole, so pi thirds divided by our whole, which again, the whole is 2 pi in radians. And then we're going to just take that proportion and multiply it by the area, which is pi r squared. When we do that, we can kind of start to see where this formula comes from, because the pi's cancel, and then this is just pi thirds, which is our theta. That's a variable to measure an angle. Pi thirds divided by 2. Dividing by 2 is the same as multiplying by 1/2. So we're just basically taking 1/2 of that angle and multiplying it by the radius squared. So that's where that formula comes from. So whether we use this or this, it's all the same. I'll just plug in over here next to this so we can make that connection. It's 1/2 times theta, which is pi thirds, times our radius, and our radius is given to us as 12. So times 12 squared. Okay, and so then if we just simplify that, we have 1 times pi is pi. So in the numerator is pi. 2 times 3 is 6. And then 12 squared is 144. Again, your calculator is available to you if you need that. And then we're just taking 144, dividing it by 6, which 144 divided by 6 is 24. So this just gives us 24 pi, which is the area of the sector when the radius is 12 and the central angle is pi thirds. And we can find that choice in selection K.